When we are doing the process of drawing a Lewis structure, which follows the 5 steps or 5 rules right here, which are also hopefully going right up here, sometimes we are faced with a unique challenge or a unique problem of not knowing whether a double or triple bond should go one place or another. In that case, it's possible to draw multiple Lewis structures that follow the rules and follow them perfectly. O3 or ozone is an example of that. When you go through the steps, you may choose to put a double bond on the left, you may choose to put a double bond on the right, and you are kind of faced with, is one of those more right than the other? The true answer to that is that they're both right, and the structure really can't be best represented by just drawing one of those. In that case, we say that this molecule exhibits resonance, or that the actual structure is somewhere between the two. We have a resonance hybrid, which is kind of an in between. In AP, most of the time we just represent it by drawing each of the structures that is correct with a double arrow between them. But the reason that we know that this is true is based upon the properties. What we see is, if we look, and the example here in O3 or ozone, when we measure the bond energy of the O to O bonds, we find out that it's not the same as if we have just a single and a double. The bond length is not the same as if we have a single and a double. They're actually kind of an average, or have a bond order of 1.5. That's halfway between a single and a double in terms of strength and in terms of energy. So the resonance idea is that we can't represent it just as this because it's not a single and a double. We can't represent it as just as this because it's not a single and a double. The drawing of both of them shows that, and shows that the most accurate way. Sometimes, and you'll see this especially deeper into organic chemistry, we show that with dashed lines, or there's other symbols to show how those double bonds are moving back and forth or alternating, or a lot of times we just say could be in either place. Sometimes when we draw multiple structures, all of them are exactly equal and the same. That is an instance in which we have true resonance. Sometimes one structure is not perfectly equal to another, and we need to understand why one might be better than the other. And we do that by evaluating where our electrons are, how many bonds the elements have, and connecting to the valence electrons. In the next video, we'll look at a specific skill that helps us to do that by following a set of steps.